Hi, it's Matthew Reed here from How to Repair Pendulum Clocks with another Reed Repairs. Today we have our sixth installment of our 3-train 18th century spring clock, and as you can see here we are focusing on the minute wheel. The minute wheel is a component that forms a gearing between the minute hand and the hour hand on the clock, but importantly as far as this clock is concerned, the minute wheel has 4 pins that release the striking work every 15 minutes. And what you can see here is that the minute cock, which is the small brass bracket that supports the top bearing or pivot of the wheel, is loose, or it's unstable. So first thing we need to do is to investigate that problem. And when we remove the minute cock, we can immediately see our problem, which is the steady pins, the 2 little metal pegs that locate the work, have been filed down and are very stumpy. So I'm going to knock those out with a hammer and fit new ones. On 18th century work like this, the screw, yes, holds the component in place, but it doesn't locate the component as such. It's these little steady pins, and you'll find them on almost all horological work. So we refit the minute wheel and realise there's still a problem. If we look here, we can see that the 4 lifting pins that release the striking are actually rubbing on the outside of the front plate of the clock, which is not at all good, causing extra friction, and maybe one of the factors that are leading to the clock being unreliable. So it's not that the pins are too long. You can actually see a little bit of wear in the front bearing as well on the minute cock, but it's the fact that the component, the minute wheel arbor, isn't uprighted. That is, it's not perpendicular to the plate. Our next stage is to place the 2 meshing components. In this case, slightly more complicated because the minute wheel comprises of 2 gears. That's the minute wheel itself, which engages with the cannon wheel in the centre arbor of the clock, and then the minute pinion, which engages with the hour wheel. So when we look at the meshing of those gears, we actually have to consider both, as in the case of the minute wheel, they are coaxial. So we place them in the depthing tool, and the depthing tool is kind of like a hinge that allows us to change the distance between the meshing gears to find the optimal level of mesh. And you can see we do that here by moving this screw in and out. So once we have our optimal depthing, we can use the depthing tool to very gently mark on the plate, and we can see here that the center distance between the center arbor and the minute wheel arbor optimally is much closer than it is in the frame. So what I'm going to do here is to move that center distance by bushing. Now, this hole has not been bushed before, so you may ask the question, why is there such a lot of change? And the answer is, I don't know. It could be that the hour wheel is later and of a slightly smaller diameter, but I don't know. The center arbor of the clock hasn't changed its position, but the depthing or the meshing of those gears is no longer functional and the wheel is no longer upright. In fact, you can see here the scoring on the front plate where the pins have touched. So I'm going to move towards our optimal depthing line by filing with a round needle file. Once I've done that, I'm going to ream the hole round and then insert a brass bush. A bush is just a sleeve of material that forms a new bearing. Here I'm using hard drawn bushing wire, which is my preferred way of doing it. It's a very high quality and durable material. and we can turn the bushing wire in the watchmaker's lathe. Here I'm using a graver to flatten the end and make an oil sink, and what I'm going to do is turn the material to a very shallow taper, pre-drill just undersized for that pivot or the other part of the bearing, and then cut off to length. Once I've cut the bush from its stock and tidied up the back, I can tap it into place using a brass hammer. There's no riveting per se or soldering needed here. We just try the pivot in the hole, and of course the pivot is too large presently. So we use a clockmaker's broach, which is a form of tapered reamer, 5-sided tapered reamer, to very slowly enlarge the hole until the pivot is a good fit. Importantly, in all horological work, the bearing needs what we call end shake, which is axial movement, and side shake, which is radial movement of the bearing to fit. If it's tight, it won't work. So with our hole in the plate changed in terms of the center distance, I noticed on the minute cock that the end has been bent round, which again will be contributing to the fact that the mobile isn't uprighted. You can see here against this ruler and the marks on the work that it's been bent round. So I'm going to bend that straight again. It's cast brass, so it bends quite easily. And just tap down those marks and then try the component in place, and we can see it spins quite freely now, and importantly it's uprighted, so the 4 lifting pins remain the same distance from the plate throughout the rotation. So all we have to do now is to reassemble the work, testing the depthing as we go, and then test the quarter striking work, that the quarter striking wheel actually does the job of releasing the striking. So there we are. Our minute wheel is uprighted, the pins are no longer touching the plate, the depthing works well now between the hour wheel and the minute pinion, and the striking releases. So thanks for watching. If you haven't already, don't forget to like and subscribe, and we will see you soon with another installment. Thanks and bye for now.